Good afternoon, and first of all my apologies for not being with you in Madagascar, but the change of date for the conference conflicted with my family holiday. So please imagine me now here. Nonetheless, I wanted to present some ideas how learning from knowledgeable others is key to mastering complex tool use in chimpanzees. This research is a group effort of the team responsible for the Thai chimpanzee project seen here on top. But it includes, lots of data of the group of PhD students that are working together with us, and of course, a large group of expert field assistants who follow the chimpanzees from nest to nest. Such research will not be possible without the reliable long-term funding of several foundations for the last 45 years. Learning skills of using tools needs time, and all tool users have a slow life history. In chimpanzees, a young is totally dependent on the mother for 5 years until being weaned. Traveling afterwards together with the mother for another 5 years, and finally becoming only more independent after 10. While females then migrate when they are 12 to 13 years old, males will be fully adult with 15 and integrated in their society. Such prolonged dependency, as in chimpanzees, allows them to learn skills necessary for many different tools. About 30 different tools are described in wild chimpanzees. They use sticks, clubs and branches, stones, leaves, as well as buttress roots and insects and all other objects to extract, fish, clean, crack, sponge, throw and manipulate other objects. Chimpanzees have the largest tool set besides humans. One of these tool-using chimpanzee populations lives in West Africa, in Côte d'Ivoire. Here in the Thai National Park, researchers of the Thai Chimpanzee Project observe wild chimpanzees since over 45 years. We follow 150 Thai chimpanzees in 4 neighboring communities every day for 12 hours and protocol their behavior using focal animal sampling. Thai chimpanzees are specialists in nut cracking. Panda demonstrates this here perfectly how it's done. He places a panda nut on the anvil and is hitting it with a heavy stone hammer until it's open to eat. This is a complex task and many things can go wrong. Usually a young chimpanzee has not properly learned what is needed right away. Here the hammer size is far too ambitious in the way Mozart is using this hammer. Here the shape of the anvil is not working and the nut rolls off. And in this case, the shape of the hammer is totally impractical. This can't work. Together with Vittoria Estienne, we looked at the ontogeny of nut cracking in Thai chimpanzees. Combining the 3 elements together, so placing the nut on the anvil and hitting it with a hammer on top, took the chimpanzees until they were 4 years old to master this task reliably. We also looked at the efficiency of cracking nuts and used the probability of success. So if they open the nut with a strike, and found that the efficiency was still improving even when 8 years old. We also looked here at the number of successful cracked nuts per minute, which also did not plateau yet when they were 8 years old. This shows that learning nut cracking is a long process. Knowing now that nut cracking takes the chimpanzees years to master, we wondered how social learning can support this and looked at peering as a proxy for social learning probabilities. In this video, Dilly is facing a problem because the deuterium nut got stuck in the shell. And she finds a solution by making a spoon to extract the nut. But have also a look to her left. There, her son Debussy is peering at her. And afterwards he goes off to find a stick and an empty shell, and he reenacts and copies what he has just seen. He imitates. Oscar Naudet-Langlois investigated how often young chimpanzees are peering at their mothers when the mothers are feeding, for example, on foods where they don't need an extraction, here in blue circles, when they extract food but without a tool in yellow triangles, or when they use a tool for the extraction, here in red squares. The hourly peering rate are highest when the mothers need to extract a food with a tool. Oscar also checked at whom the youngs are peering at when they are not peering at the mother. And as you can see here in blue, the hourly peering rate is highest when the model is an adult, so a knowledgeable other individual. Oscar investigated if young chimpanzees go again and peer more often after they failed to reproduce the task. And you can see this curve here in purple, where the probability to peer after failing is higher and much faster than when they managed to successfully, like here in yellow, reproduce the task they had looked at beforehand. So in summary, we can say learning of complex tool use happens over many years. And in nut cracking, it takes chimpanzees 4 years to put the 3 elements correctly together, and only after 10 years they are really efficient. They use peering at actions to learn, and the more complex a task is, the more peering happens. Younger ages of chimpanzees, peer more at mothers than older ones. But they're all the time peering at tolerant and knowledgeable models. Finally, if a chimp has failed in reproducing the task it has seen, it returns faster to peering than when it has done this task successfully. And with the summary of how important peering and social learning is to manage and understand complex tool use, I say merci beaucoup. And if you have questions, please visit us on the internet or on our Blue Sky account. Thank you.